The slope-intercept form, y equals mx plus b, a quick lesson with a few exercises for you to try. Slope, it's the name of the thing that we give to the slant of a line on the coordinate plane. It's simply the rise over the run, and it can look just like a fraction. The rise is the numerator and the run is the denominator. Slope? Well, you see, it's the slant. It's something like that, or it's something like that. And it's the rise. Here we have a rise of 1 over a run of 2. And so let's see what that looks like. Here we have a run of about 2 and a rise of 1. So if we connected the ends of those, we would have something that you might call the hypotenuse of a right triangle. It's the slope, and it's what we call the slanty lines on the Cartesian coordinate system. It's just the rise and the run in a fractional form. So the rise is the numerator and the run is the denominator. They can be positive and negative. We can have positive fractions, we can have negative fractions, we can have positive slope, negative slope, we can even have 0 and no slope. Positive slope, that's when, here we have, I have a positive 1 here, and I have a positive 1 here, and so this is just a rise of 1 over a run of 1, and so this would be a positive 1 slope. I can have a run of 2 here, and a rise of 2, and 2 over 2 is the same thing as 1, and so that's still a positive 1 slope. I can have a negative slope, and so a negative slope, I go down, and so here we have a negative slope of 1. So if I go down 2 and over 2, down is a negative here, so I went down 2 and I went over 2, and this was a positive 2. So I have negative 2 over 2, and that gives me a negative 1 slope. And I can go down 1 over 1. I can go down 3 or 4 and over 4, and I'm still dealing with a negative, so I've got a negative 4 over 4, and it doesn't matter if the 4 is in the numerator or the denominator, so I still wind up having a negative 1 slope. I have no slope, and no slope is when you have no run, and we can't have a 0 in the denominator, so we say that that is no slope, and no slope is a line that's straight up and down, and you can remember that because it's parallel with the part of the n here. It makes it no. And then we have 0 slope. 0 slope is when you have no rise, and when you have no rise, you have a 0 in your numerator, so you have no rise there. And I remember that because the z, the bottom of the z, is parallel to the 0 slope line, so here we have 0 slope. A line on a graph can be represented by an equation. For example, we can have y minus x equals 0, and you can think of an uncountable number of things that we could insert in there to equal 0. So I could have 2 minus 2 equals 0, and it just goes on forever and ever. And then we could plot those. Here's our x, so we could plot the x as 2 and the y as 2, or negative 2, excuse me. And so we could plot that, and we would still wind up with 0, and we'll take a look at how that works. We can massage this a little bit so that instead of having y minus x equals 0, we can pick up this minus x and we can move it to the other side, which then just sort of cancels out the 0 there. And so we wind up with y equals x. And that's kind of the form in which we're going to be trying to get here with the slope-intercept thing. Now, for each y that we have an x that's the same. So we have 0, 0 if y is 0, x is 0. You know, if y is 1, x is 1. If y is negative 1, x is negative 1, and it just goes on and on and on, and we can actually graph that. And if we made a quick sketch of the graph, it'd look like this green line here. We have a positive 1 slope. And so for each one that we go over, we go up 1, and that gives us a positive 1 slope. Now, though, let's enter the land of the slope-intercept form, this y equals mx plus b, and we'll find out what is so magical and special about the b and the m. and they help us find out this information right here. All right, so we have the y equals x equation. It was a simple one, so let's take a look at one that's a little bit more complicated. And the one that's a little bit more complicated, we'll take a look right here, and we'll say y minus 2x equals 4. And we could hammer this away. We could try to figure out what is some x value that will fit into this, and what is some y value that will fit into this, so that will equal 4. And it turns out that it's actually fairly easy to do. You can just hammer away on that. And so if I say that y is going to be 6, and that would mean that my x is going to have to be 1, and if I go ahead and crunch that out, I have that right here, and I can see that, yeah, that works, that satisfies. If y is 6 and x is 1, it equals 4. And if I take a look at the next one, if x is 0, y is 4, it satisfies the equation. And if x is negative 2 and y is 0, it satisfies the equation as likewise. So that took a lot of work. The slope-intercept form will actually help us be able to plot lines fairly quickly, and so we're going to take a look at that. If we plotted this, which we did, all the three that I just kind of hammered out, I'd get a slope of a line that looks about like this, so you can see, oh yeah, it's about positive, and we'll take a look at how this y equals mx plus b thing is going to help us. Here we have the slope on that. So let me show you, if I can get this into the y equals mx plus b format, how that could be helpful for you. And so let's see, I want to get y on one side by itself, and here I have a negative 2x on the wrong side of the equation mark. So if I just pick that up and move that over to the other side, what happens is it changes the sign. So I now have, or we could say, well, I'm just adding a 2x to each side. I like to think of just picking it up and moving it. So I now have y equals 2x, and my 4 is positive, so it's plus 4. And now, let's look what happens to our equation, our line that we beat out over here. And so, let's see, this m thing that was right here is a positive number 2. And if I look over here, so now what happens is, the slope of my line is 2, and the y-intercept happens to be 4. And the reason that is, let me show you this here. The reason that is I can say y equals 2, and if x equals 0, I'll just plug in a 0 here, and it was plus 4. And what happens here is when any number is multiplied times 0, that itself becomes 0, and so y will simply equal whatever that b is. And so that's why that b is important. I'm not sure why it's a b, but maybe we'll find out one day. So what happens? We take a look at our equation over here, and I cross the y-axis at b, so when x is 0, y was 4, and the slope of my line was a positive 2. And so that meant I went over 1, a run of 1, with a rise of 2. A run of 1, rise of 2. Remember, it was just a fraction, and so we have 2 over 1 is our rise, 2 is our rise, 1 is that, and so now our slope of our line was a positive 2. Let's take a look at another example here. So I have y minus 3x equals 2. If I want to just move this over to the other side, this will change to a positive, and so I wind up having y equals 3x, and my 2 is positive, plus 2. Now, I know that the slope of my line is going to be 3, and I know that I'm going to cross the y-axis at 2. So I come over here, that's 1, that's 2. There's where I cross the y-axis, I intercept the y, and my fraction here of 3 over 1 is my fraction, so I go positive up 3, 1, 2, 3, over 1. And then I go positive 3, 1, 2, 3, over 1, and plot my point, 1, 2, 3, and over 1. Plot my point, and put a straight line on that, and it would look something about like that. So that's the way you would graph this. You really only need to plot 2 points if it's a straight line. Okay, let's try another one. Let me work this out here. My coefficient of y happens to be a positive 1, so I don't even have to worry about that. And I'm just going to take this positive 4x and I'm going to move that to the other side, which is going to make it a negative 4x. So I wind up having y equals negative 4x. So I have y equals negative 4x minus 4. There's the slope of my line, negative 4, and I cross the y-axis at negative 4. So I come over here and I say 1, 2, 3, alright. There's negative 4, and I've got a negative 4 slope. Remember, that's a negative direction right here, and 4 in a fraction form is just 4 over 1, and the negative can go here, or I could say 4 over negative 1, and that's still a negative 4 slope. So what that means is I'm going to go up 4, 1, 2, 3, 4, and since I went up 4, I've got to go negative 1, and that was 1, 2, 3, 4, and over 1, and I've got a couple of points there, and if I had a straight line, I could put the straight line on there, and I'd have a slope that looked something about like that. Right now we're just sort of sketching it in. Alright, here's the way this works. I want you to get a piece of paper and a pencil, and you're going to click on the stop sign here. So if you click on the stop sign, if you're watching this on YouTube, it actually pauses the video, and then you can see the problem. You will then try to work out the problem. When you're ready to see it worked out, come back along, click on the go sign, and when you click on the go sign, I'll show you it worked out. So click on the stop sign. Alright, let's see how you did. Well, let's see. I got to get positive y on one side by itself, and I have a couple of options here that I could do. I'm actually going to take a look at this. What I really have here is I have a negative 1 that's connected with my y, and this is a positive 3x, and this is a negative 6x. And I'm looking at this, and so my thinking at this point is I'm just going to divide everything by negative 1. If I divide everything by a negative 1, then it kind of simplifies a lot of stuff, and it also gets the y exactly the way I want it to be. So this negative cancels. That negative, y over 1 is simply just y. And so now what I have is I have 3x over negative 1. That just becomes negative 3x. I've got a negative 3x here. But I want to move that to the other side, which means that its sign changes again, so it becomes a positive 3x again. So we have a positive 3x, and now I have a negative over a negative. They cancel each other. I have 6 over 1, and that's just 6, and it's a positive, so now I have 6. So I'm in the slope-intercept form. I'm going to cross the y-axis at 6. 1, 2, 3, 4, 5, 6. And then I'm going to come in, and my slope is a positive 3. So it means my slope will be something about like that. So I'm going to go down 3. 1, 2, 3. That was a negative amount. But then if I go a negative 1, the slope of my line will be positive. Because this was a negative 3, and this was a negative 1. And that's it. So I can plot my 2 points that way, put my straight edge there, and take care of that. You might ask yourself, why are we doing this? What's the value of this? Well, let me give you a quick demo on that. Let's erase some stuff here to get the stuff out of the way, and so that you can see that a little better. What turns out is if I had done a really good job of making my graph, which I can't tell you that I did a great job of making my graph, if I'd done a really good job of making my graph, any point on this line would satisfy this equation that I have up here. And that is, if I wanted to see where the graph, where this crossed the x-axis, in other words, this is where y is 0, I would know what x is. And so I could look at the graph, if I'd done a good job, and would be able to tell what these numbers are. Because you see, any number on this line, any 2 numbers, will satisfy this equation, so that it would be negative 6. And that can be pretty important later. Alright, let me show you how this one works, and then I'll let you do one for yourself. I have a coefficient of 2 connected with my y. It happens to be a positive 2, so I'm just going to divide everything by 2, divide everything by positive 2, and divide by positive 2. Let's see. This 4 cancels out with that 2 and just becomes a positive 2x. This 2 cancels that 2. And it doesn't cancel go to 0. It goes to a 1, actually. And so 1 times y is y, and y over 1 is y. So it's a positive y. And 8 divided by 2 is 4. Now I want this positive 2x to go to the other side, so I move the positive 2x to the other side, and the positive 2x moving to the other side becomes a negative. So I wind up with y equals negative 2x plus 4, because my 4 was positive. I know now that I'm going to cross the y-axis at 1, 2, 3, 4. So I'm going to cross the y-axis right there. That's when x is 0. And my slope is going to be negative 2. That's a negative slope, like there. That's not quite a negative 2. But what does a negative 2 mean? It means negative 2 over 1. And so I go, if I go up 2 over 1, up 2 over 1, I have now made my my graph. And if I'd used a straight edge and been careful, I would have done a very good job. All right, click on the stop sign, get a piece of paper, see how you did. Try to work this one out. All right, let's see how you did. I'm going to divide everything by 2 first, because it's a positive 2, and I want this to ultimately just go away. And so I get 2, 2, and 2. And so this 2 cancels that 2, becomes 1, becomes 1. 1 times x is x. X over 1 is just x. Plus y equals negative 2. Negative 2. Now I want to move the x to the other side, so I have y equals negative x minus 2. And so y equals negative x minus 2. I'm going to cross the y-axis at negative 2, and my slope is going to be a negative 1. I go down 1 over 1, make my dot. Down 1 over 1, make my dot. Or I just continue going like this, and that's the slope of my line. This is the slope of my line, and it's something about like that. So if you sketched it out like that, you're doing it right. All right, click on the stop sign, see if you can work this one out yourself. Okay, I am going to divide everything through by a negative 10, because negative 10 is the coefficient of my y, and I want it to be a positive 1. And so I'm going to divide everything out. Negative 20 over negative 10 becomes just a positive 2x. And negative 10 divided by negative 10 means that that just becomes a positive y. And let's see, I get 200 divided by 10, that's just 20, and there's a negative sign there, so the whole thing's negative 20. And now I got a 2x that I need to move to the other side. It will become negative, so I have y equals negative 2x minus 20. And remember, that's just the same thing as the fraction 2 over 1. So I have a problem. My graph isn't large enough. It turns out, I guess, if I use that as 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, is that correct? Then I would have, that would be my 20 mark. So I have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Yeah. And what's my slope? Let's see. I'm going to go up 2 and negative 1. That'll give me the same thing. So if I go up 2 and negative 1, it looks like this. I go up 2 and negative 1, it looks like that. And if I go up 2 and negative 1, it looks like that. And that gives me some points to hit, so it's easier for me to draw the line. And so the slope of my line looks something about like that. If you got that in a quick sketch, you're getting it right. Now, obviously, when you're doing a really meticulous graph, you'll want to take more time. But getting a sketch, getting a picture of what it's really going to look like is pretty important. All right, click on the stop sign and give it a whirl. Let's see how you did. I'm going to divide everything through by positive 15. So positive 15, positive 15, and positive 15. Let's see, that becomes negative 2/3. Negative 2/3, so if you got that one, you're right. And it's an x, negative 2/3 x. 15 divided by 15 is 1, so that just becomes y. And here we have 4/3. And I know you're freaking out because you're saying, oops, I've got all these fractions, I don't know what to do. Well, hang in there, buckaroo, we'll make it happen. I'm going to move this negative 2/3 x over to the other side, and so I'm going to have positive y equals 2/3 x, change sign, 2/3 x, so my slope is going to be 2/3, and it's not all that difficult, I'll show you that. And I'm going to cross the y-axis at 4/3. Well, we come over here, and I say, there's 3/3 right there, it's the same thing as 1. And so 4/3 is just 1/3 more. And so I'm going to cross the y-axis just a little 1/3 of the way above 1. And so now my slope, I'm going to go up 2. So there's 1, 2. And then I'm going to go over 3. 1, 2, 3. And I'm going to plot my point. That's it. See? This is a whole number. This 2 right here, it's a whole number. So I went up 2. And this 3 right here, it's a whole number. I went over 3. Yeah, my slope might be a fraction. But my rise was 2 and my run was 3. And those are whole numbers. So then I put a straight edge on this puppy and I get some sort of a slope that looks about like that. It's positive and it's a 2/3 slope. Alright, let's see. We just did that one. And we'll work on this one. Oh, let's see. Click on the stop sign. Come back after you've tried. Alright, I'm going to divide everything through by negative 6. Negative 6, negative 6, and negative 6. And so that negative cancels. I have 3 over 6. That's the same thing as 1/2. And it's 1/2 x. And negative 6 cancels negative 6, so that becomes a positive y. And all of that is equal to 12 divided by negative 6, which is the same thing as negative 2. I'm going to pick up this 1/2 x and I'm going to move it to the other side. And when I move it to the other side, it becomes negative, because it was positive. And so I now have y equals negative 1/2 x minus 2. And so now what happens is I come over and I say my y-intercept is negative 2. So I plot a point at negative 2. And the slope of my line is going to be negative, so it's going to go like that. My rise is going to be 1. My run is going to be 2. And one of them has to be negative. So if I rise 2, I go negative 1. Rise 2, go negative 1. Rise 2, go negative 1. Those corners are where I plot my points, and that's how I plot my line, and it goes something about like that. So that's the way that happens. So you should have a graph that looks about like that. Your comments, questions, and suggestions are welcome, encouraged, and always appreciated. You may write to me at alanmorris@yahoo.com.